Use the source.
Okay, doing a little problem solving. So we're using different approaches, different ways to try to come at a solution here. So let's read this problem. So a thin tube stretched across the street counts the number of pairs of wheels that pass over it. A car with 2 axles registers 2 counts. A light truck with 3 axles registers 3 counts. During a 1-hour period, a traffic counter registers 35 counts. How many cars and light trucks passed over the traffic counter, assuming no other types of vehicles? So we're just sticking with the scenario of cars and trucks, because if we take into account semis with a trailer and all these other things, that's going to make things a little more difficult. So we'll work on just this sort of basic problem. So, well, lots of ways to do this. I think a nice way would be to try to come up with a table. All right. And the table of results would work really well. So, for example, you need 35 counts, right? So let's see here. If it's a car with 2 axles, so maybe we make a column in our table that says car. And I'll put a parentheses in 2 because that counts as 2 axles, right? And then we have a truck with 3 axles. So what total does that give me? Now if I make this table, I can just try all sorts of combinations in my table, and then the combinations that end up with a total of 35 would be possible answers. So for example, maybe I had 1 car, 0 trucks. Well, 1 car is 2 axles, so 2 counts. So that's a total of 2 counts. Okay, not enough, obviously, so that's not going to work. 1 of each, well, that's 2 counts for the car, 3 counts for the truck, for a total of 5 counts. Okay, not going to do it. But I could keep going this route, so maybe 4 counts. Well, actually, I should really try to do this systematically, right? So maybe 2 counts, 1 count. So 2 counts for 2 cars, that's 4, plus 3, that's 7. Not quite enough. Maybe 1 and 2, 6, and that's 8. Blah, 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 blah. So this could work. It's going to take a while. So what's another method? I'm going to do a quicker method. So that method I just started with the table could work, but it's going to take a while. So let's be smart though. 35 counts. Well, 35 is odd. Well, how are we going to get an odd number of counts? Well, the only way we can get an odd number of counts is if there's 1 truck or an odd number of trucks. Right, and the reason why is because if this is odd, there must be an odd number in here somewhere, because cars are always an even pair, right? 2 axles. So if they were all cars, it would have to be an even number of counts, but it's not. And it's 1 truck or an odd number of trucks, because if you had an even number of trucks, that would be an even number, right? So like 2 trucks, that's 3 counts, and 3 counts, that's 6 counts. That's an even number. All right, so this is going to really, really help me out now. So now I can break this down and do all sorts of combinations. So maybe there's only 1 truck. And therefore, if there's 1 truck, that is 3 counts. So 35 minus 3 is what? 32. And now the rest are all cars. Cars that count for an even number. So 32 divided by 2 is 16. So 16 cars. I can't have an even number of trucks, so no more, not 2 trucks. Let's jump up to 3 trucks. Well, if that's 3 trucks, that's 6 counts, right? Because there's, excuse me, not 3 counts, 9 counts. because every truck counts for 3. 3 times 3 is 9. So what's that? 35 minus 9. That would be 26. Divide that by 2 axles per car. That's going to get me what? 13 cars. Now let's jump up again. Remember, you can't have an even number of trucks, so maybe 5 trucks now. 5 trucks, 3 axles per truck. 3 times 5 is 15. 35 minus 15 gets me down to 20. Divide that by 2 to tell me the number of cars. That's 10 cars. 7 trucks. So 35 minus 7 trucks, 3 counts. 7 times 3 is 21. 35 minus 21, that would be 14. Divided by 2, 7. Now a lot of you probably see the pattern. 9 trucks. So this goes up 2 every time. This goes down 3 every time, right? So now what? 7 trucks, now down to 4. Excuse me, 7 cars, now down to 4 cars, minus 3. 11 trucks, down to 1 car. So there's all your possible solutions. So while that table we started with could have got us the answers we seeked, it would take us a long time. This was a little bit craftier way to think about it, and we could come up with a solution a lot faster.